in an energy level. The maximum number of electrons in an entire energy level.
With all the orbitals that that energy level could hold. So if we're at the first energy level, it's simple because it's just the s, 2 electrons. But at the second energy level, what happens?
At the second energy level, there are 2 different sublevels present. There is s, with its 1 orbital, and there is the p sublevel.
Yeah, I don't have enough hands for this.
Yeah, there's the p sublevel as well, with its 3 orbitals. 2 electrons in here,
Yeah.
2 electrons in here, 2 electrons in here, 2 electrons in here, for a grand total of 8 electrons.
8 electrons. You know, on the periodic table, how many boxes, how many elements across are there in row 2? Because row 2 is energy level 2, and if we count, I don't know if we can see this on camera or not.
3, 4,
Yeah.
5, 6, 7, 8. Oh, wait a minute. There's 1, 2, kind of like S.
Kind of like the s orbital.
And then
There's
there's
2 over there.
3, 4, 5, 6, 7, 8. Hold on.
Okay.
There's 1, 2, 3, 4, 5, 6, 7, 8.
8 elements across because there are room for 8 electrons in that energy level. And they go into these sublevels.
A coincidence?
I think not.
I think not. That's exactly right.
Alrighty, hint number 27, which is test question 7. What do the S, P, D, and F represent? So, go back to the 4 quantum numbers, which are letters. Which one of these is associated with the SPDF? Mr. Zosky?
This one.
That one.
This one. This is the orbital quantum number, which actually refers to the shape,
The shape of the orbitals.
of the orbitals, whether it's S spherical or D double peanut. That's this one.
Right.
Okay.
So we might ask you about a specific energy level, a specific orbital, but if you know SPDF and that shows the orbital shape, you're good to go. All right.
28, the direction of spin for electrons. Electrons. I gotta go.
Yeah,
Keep going. Okay, yeah, I gotta go this way.
Gonna be dizzy.
Kind of like gears. Okay, that's enough.
Yeah. We're not gonna make it through this.
They spin opposite of each other. One of them goes in a clockwise fashion, and the other one goes in a counterclockwise fashion.
Right. Because otherwise, the electrons are going to repel each other because of their negative charge. When they spin, they're like little electromagnets, and there's a little bit of a magnetic attraction between the electrons that lets them stay together in that orbital, even though the charge makes them want to repel. So with spin, only 2 ways to go. It spins clockwise or it spins counterclockwise. We draw it as an up arrow or a down arrow. Yeah, good job.
Yeah. 29, which is question 9 on the test. The different orbital shape. Can we stop doing that?
Oh, yeah, I guess.
Okay.
Yeah.
The different orbital shapes that are possible at each energy level. And again, we're looking at what orbitals, what sort of sublevels, S, P, D, or F, are present on each energy level. On the first energy level, you only have S.
Right.
On the second energy level, you have S and P. Third energy level, S, P, D, and moving up along
To SPDF,
D,
and the
F
4th
on
energy
fourth.
level, and the 5th and the 6th and the 7th. But if we discover new elements, there could be room for more. We just don't need them yet.
Absolutely.
Okay.
Absolutely.
Alrighty.
20
No, number 10.
or 30.
30.
Yeah.
What does the Aufbau principle mean for an atom? Aufbau, on, build on. If you go to a concert and it is your favorite performer ever,
Mozart. Although he's not performing live anymore.
AC/DC.
Beastie Boys.
Okay, fine. If you could go to a concert hall and be the first person to pick what seat you want to sit in, are you gonna sit way up in the nosebleed section, far from the stage? No. You're gonna sit front row center, as close to the action as you can, because like you totally love this group. Well, the electrons are really attracted to the nucleus. The nucleus is very positive, it's got all of those attractive protons in it. The electrons want to get close to it. That's what they were doing all the quantum jump stuff and giving off the color and the light, because they wanted to get back close to the nucleus. So in the Aufbau principle, we know that the electrons are going to fill in around the nucleus first, and then if there's not enough room there, then they'll fill in other layers or levels further away. Okay? It's pretty simple. Aufbau, build on. So we start at the lowest energy level, and we build up and fill in electrons from there. All right.
That's it. 31. How to find the number of outer energy level electrons for a specific element, specific atom.
I think, they know the name of those outer level electrons. They came into chemistry already knowing that word.
Oh yeah. They've known this for at least 2 years.
Right.
It was the valence electrons.
Valence electrons.
Those valence electrons. And how is it that they determine this?
How many are in the outer level?
So in this particular question, they might have to look at either orbital diagrams or an electron configuration, and they might have to figure out,
or even just the element. We might tell them what the element is.
Tell them what the element is, and then say, hey, how many? So they would have to create their own orbital diagram or their own electron configuration, and then identify the outermost energy level.
Right. But the cool thing, because we referenced the periodic table before, is that it's a big giant cheat sheet. So you can look at how many boxes over. And so if we said to you, how many outer level electrons are there in magnesium? You'd go over to your periodic table and say, oh, magnesium is 2 boxes over in that row. It's in the S block. We know all about that. We colored it in and so on.
The custom colored periodic table.
Right. 2 valence electrons.
Yep.
So it's a question that's really that easy.
Yes.
All righty.